Coking is a carbon rejection method achieved through the severe thermal cracking of heavy hydrocarbon feeds, most typically vacuum resid feeds. The rejected carbon takes the form of petroleum coke, which is then calcined in further steps to remove entrained hydrocarbons. Green coke is defined as the coke product directly from the coker. Carbon content can be further increased by calcination at temperatures between 1800 and 2400 degrees Fahrenheit or 980 to 1315 degrees Celsius. The three main processes of coking available to refiners are delayed coking, flexi-coking, and fluid coking. Delayed coking is considered to be the dominant technology due to its ability to enhance refinery liquid yields from a wide range of residual feed streams. Delayed coking, which is the most popular method, involves the feed being charged to the bottom of a fractionator where it is refluxed against hot vapors entering from the in-service coke drum. The fractionator bottoms are then sent through a fired heater to a large coking drum at a high velocity, which shortens the residence time in the horizontal heater tubes and delays the bulk of the coking reactions until the drums are reached, hence the name delayed coking. A stream of heavy coker gas oil is condensed while the remaining vapors are cooled and separated into gas and liquid products as they ascend through the fractionation tower. A generalized diagram of the delayed coking process is depicted in this figure. Coke collected in the drum have three general categories. Needle coke exhibits microscopic anisotropic particles and evolved from processing aromatic feedstocks at high pressures greater than 100 psi gauge or 690 kilopascals and high recycle ratios, such as 1:1. Sponge coke is characterized by irregular particles ranging from 50 centimeters or 1.64 feet down to dust. It is typically produced from low sulfur, low metals vacuum resids. Shot coke is usually an unintentional product when processing very heavy residual feeds. The particles can exceed 20 centimeters or 0.66 feet, but are not a useful product as the particle surface areas are much less than sponge coke, and they do not have useful characteristics for manufacturing electrodes like needle coke. Refineries can produce three types of coke: fuel grade, which include shot, sponge, or a combination, anode grade, and needle grade. The morphology, typical feed characteristics, impact on coker operations and yield, primary outlets, and demand of the three grades of coke are summarized in this table. The coke in the drum is used for fuel. The manufacture of anodes for electrolytic alumina reduction. As a carbon source for the production of elemental phosphorus, calcium carbide, and silicon carbide. The manufacture of electrodes used in electric furnace production of phosphorus, titanium dioxide, calcium carbide, and silicon carbide. The manufacture of graphite and is feedstock to a gasifier for utilities and/or chemicals production. This table summarizes the benefits and drawbacks of vacuum tower bottoms, vis breaker bottoms, FCC slurry oil, and vacuum tower slop wax as coker feeds. Much of the feed streams to cokers may be blends of mixtures of vacuum residue, vis breaker residue, slurry oil, unconverted oil, and slop wax. Vacuum tower bottoms is considered to be an ideal feed for a coking unit as distillate yields are generally good and the coking rates in the heater are relatively low. Also, feeding vacuum tower bottoms to the unit is the simplest method for cokers. Vis breaker bottoms will have lower liquid yield and higher coking rates, may exhibit asphaltene stability problems, high fouling rates when exposed to oxygen, and have high viscosities unless blended with lighter material, such as FCC slurry oil. Blending a lighter material like FCC slurry with vis breaker bottoms can increase asphaltene solubility depending on aromatics content. FCC slurry oil, on the other hand, may contain some amount of catalyst fines even after being subjected to a solids removal process, and these fines can increase coker heater fouling rates and negatively impact petcoke quality. Vacuum tower slop wax is generally recommended as a blending material as it will contain some amount of distillate depending on the operation of the vacuum tower.